more simultaneous equations. Now we're going to use examples that are not as simple as the previous lesson. For example, the first question, we have 3x plus 2y equals 11, and 2x minus y equals minus 3. Equation 1, equation 2. As you can see, neither x or y have the same coefficient. 3x here, 2x here, 2y here, minus 1y here. So here we need to decide which letter to eliminate. As I explained the previous examples in previous lessons, it doesn't matter which letter you want to eliminate. But sometimes one letter is better. Never wrong, but better. For example, here, I would think eliminating y would be better than eliminating x. My only reason here is the signs of y is different. So when I make the sign, when I make the numbers of y the same, then by adding I will get rid of y. So the technique to make the letter you want to eliminate to have the same coefficient is to use the coefficient of that letter in first equation, give it to the second, and from the second to the first. So first I'm going to mention I'm eliminating letter y. Since I've got 2 here, just the digit, not the, I want to keep the sign. Since I've got 2y here, I multiply the second equation by 2, and since I've got 1y here, I times the first equation by 1. Make sure you multiply this right through. 1 times 3x, 1 times 2y. So 1 does not change anything when you multiply. Every number times 1 remains the same. Here, 2 times 2, so we have 4x. 2 times minus 2y is minus 2y. 2 times minus 3 is minus 6. I'm going to add, because I know by adding plus 2y to minus 2y, the y will cancel. So add column by column. 3x, add 4x, that's 7x. Plus 2y, minus 2y, no y. 11, take away 6 is 5. So here, by dividing both sides by 7, x equals 5/7. The same as a previous example, we are going to substitute x equals 5/7 in one of the equation of your choice. If you are not happy to use the equation with the negative value in it, you can use that one, although the coefficients are heavier. So I'll go for substituting in equation 1. I write equation 1. And I do as I've written here. Substitute x equals 5/7 into here. So we have 3 lots of 5/7 plus 2y equals 11. That is, of course, 15/7. Emphasize again, when you multiply a number by a fraction, that number belongs to the top, multiplies by the top, not both top and bottom. Removing 15/7 from both sides. So we have 2y or plus 2y equals 11 minus 15 sevenths. Writing 11 as 77 sevenths. So 2y equals 62 sevenths. Therefore, single y equals 31 sevenths. Dividing both by 2. Dividing 2y by 2 becomes 1y. Dividing 62 sevenths becomes 31 sevenths. More examples on simultaneous equation. X minus 2y equals minus 4, and 3x plus 1y equals 9. Again, equation 1, equation 2. Again, I look at the unknowns x under x, y under y, equals under equal, constants on the other side. Then I look for, see which letter is better to eliminate. Since y has got difference in sign, I go for y. So I will tell the examiner, eliminate letter y. As from the previous question I did, you use the coefficient, the digit really, not the coefficient, the digit multiplied by y from the first equation and use it to multiply all of equation 2 by that. The digit next to y here, which is 1, is used for the first equation. So it's like a cross that comes here and that goes there. The rest is to multiply, making sure you multiply right through. So 1 does not change the coefficients. Top line remains as top line. Bottom line 6x plus 2y equals 18. You can see now that technique made the number of y's the same. 2y, 2y. One is negative, one is positive. So by adding x and 6x, we have 7x minus 2y plus 2y, 0y, no y. Negative 4 add 18 is 14. Then I'm going to write both sides and divide by 7. So x equals 2. For finding the other letter, we need to substitute. So here, substitute x equals 2 in equation 2, because they're all positive terms. Let's write equation 2. 3x plus y equals 9, but x is 2. All substitution to be made inside brackets. That eliminates all mistakes. 3 times 2 is 6, plus y equals 9. Remove 6 from both sides. Here, 6 cancels, y equals 3. You can check your answers in the equation that you did not use for substitution. This check is merely for your own benefit. So check in equation. Since we use 2 for substitution, we use 1 for checking. So x minus 2y equals minus 4. Let's check. X was 2 and y was 3. Will I get minus 4? 2 minus 6 equals minus 4. 2 minus 6 is minus 4 equals minus 4. That means both my answers were correct for this question. More examples. We have 3x plus 2y equals 7, and 2x minus 3y equals minus 4. I check, I can see x, y, and the numbers and equal sign, they're all in the same column, and I decide to eliminate either x or y. The coefficient of x are different, 3 and 2, so is for y, 2 and minus 3. But because y has a different signs, I choose y, because I can add and get rid of, so eliminate y. The problem is both y's here don't have the same coefficient. One is plus 2, one is minus 3. So the technique was to use the coefficient of 2, or the digit next to y, in equation 1, and multiply that number by equation 2. So 2 from here comes here, and 3 from here goes there. Let's multiply. Three times 3, therefore 9x. 3 times 2y, 6y, equals 21. 2 times 2x, 4x. 2 times minus 3y minus 6y, equal 2 times minus 4, which is minus 8. If you look here now, the number of y's are the same, or we made it the same, with a different sign. So let's add. 9x add 4x, that's 13x. Plus 6y minus 6y, no y. 21 take away 8 is 3. 13. Sorry. Divide both sides by 13. X equals 1. Now, sub x equals 1 in equation number 1. Let me write equation number 1. They're all positive terms. Substitute inside bracket. So we have 3 plus 2y equals 7. Remove 3 from both sides. 2y equals 4. Divide both sides by 2. Y equals 2. Now, let's check in the equation that you did not use for substitution. So check in equation 2. Write equation 2 down, which was 2x minus 3y equals minus 4. X is 1, y is 2. 2 minus 6 equals minus 4. Yes, 2 minus 6 is negative 4 and equals negative 4, so that means our answers were correct. More examples of simultaneous equation. This would be the hardest type, where numbers of x and y are different, yes, and the signs are the same. That's the problem. So when we add, they're not going to disappear. You see, if I make x the same, when I add, they will not disappear. Here, if I make the number of y's the same, when I add, will not disappear. So here, slightly one extra step. Deciding which letter we want to eliminate. In my opinion, just as bad as each other. 3, 4, 2, 5. So I just decide to eliminate x, for example. Eliminate x. So since we have 3x here, I multiply the second equation by 3. Here, 4, I multiply the first one by 4. And then I multiply through. So I will have 12x plus 8y equals 16. Times, times, times. 3 times 4, 12x. 3 times plus 5y is plus 15y equals 30. You can see now the letter I wanted to eliminate, x, has now got the same value, 12, 12. Now, some teachers will tell you to take away. They say, okay, since by adding you can get rid of it, take away. Either the bottom from top or top from bottom. For example, you have to do this mentally. 12x, take away 12x. 15y, take away 8y. 30, take away 16. I do the same thing, except I change the sign of one of the lines and then add. For example, I choose to change the sign of the top line. At the moment, 12 is positive, so I put negative under the existing sign. Positive becomes negative, positive becomes negative. So the red signs are changed by me. These are called the new signs. Then I'm going to add now. So I never take away. My takeaway is changing the signs and adding. With this method, you make less mistake because you can see what you're doing rather than doing it mentally. Minus 12x plus 12x, no x. Minus 8y plus 15y, that plus 7y. Minus 16 add 30 is 14. Then we divide both sides by 7. So y equals 2. Then you can go and substitute as before in one of the original equations. In this case, sub y equals 2. In equation, say 1. You have got a choice. 3x plus 2y equals 4. Original equation 1. Replace y is 2. So 3x, y is 2. 3x plus 4 equals 4. Remove 4 from both sides. So 3x equals 0. Dividing both sides by 3. X equals 0 divided by 3, which is 0. Okay, we substitute in equation 1. Let's go and see if our answer mentally, instead of writing, would check in equation 2. 4 lots of 0, which is 0. 5 lots of 2 is 10, equals 10. So mentally I checked, and both answers are correct. More examples here. Where again, the signs are the same. 5x minus 7y equals 27. And 3x minus 4y equals 16. Equation 1, equation 2. Now, the digits next to x are different. The digits next to y are different. The signs of x are both plus. The signs of y are both minus. So they're both as bad as each other. We need to eliminate one of the letters. The choice is mine. I'll go for x. We can go for y if you wish. So eliminate x. Since I'm eliminating x, 5 here is multiplied by the second equation. Here x is 3 here, 3x, and multiply this top one by 3. So that's gone there, and that's gone here. Multiply right through. Three times 5x is 15x. 3 times minus 7 is minus 21, therefore 21y. And 3 times 27 is 81. 5 times 3x is 15x. 5 times minus 4y is minus 20y. 5 times 16 is 80. Now put a line under. And as always, add. But by adding 15x and 15x, you don't get 0x because the signs are the same. So choose the sign of one of the lines to be altered. You can't just change the sign of a term x. You have to do all the terms in that line. So I'm going to change the plus 15 to minus 15x, minus 20 to plus 20y, and then plus 80 becomes minus 80. So the red signs are the new signs, which I'm going to use for adding. 15x minus 15x, no x. Minus 21y plus 20y, that becomes minus 1y. 81 minus 80 is 1. Now, I haven't found y yet. I found minus y, and minus y is minus 1y. So here I'm going to divide both sides by minus 1. So minus y by minus plus, y divided by 1, plus divided by minus is minus, 1 divided by 1 is 1. You would have got the same if you had changed the sign of the top number. If you had changed the sign of the top number and add, you would end up with plus y equals minus 1. You probably would have got the answer quicker, but it's not a problem. Now sub y equals minus 1 in equation of your choice. Let's use equation 2, which is 3x minus 4y equals 16. 3x minus 4 lots of minus 1 equals 16. 3x plus 4 equals 16. Remove 4 from both sides. 3x equals 12. Divide both sides by 3. So x equals 4. Let's do a mental check. In the equation that you did not use, you use equation 2. Let's go and see if we can satisfy the equation by replacing x4 and y minus 1 in equation 1. Best to write it then. Equation 1 is 5x minus 7y equal 27. 5 lots of x, 5 lots of 4, minus 7 lots of y is minus 1. Does that give me 27? Yes, that's 20. Minus times minus is positive. 7 times 1 is 7 equal 27. As you can see, 20 add 7 is 27. That means both answers were correct. Final example on simultaneous equations. here we have x plus 3y minus 7 equals 0. And 2y minus x minus 3 equals 0. With this one, I've made life very difficult for you. You can see x is not under x, y is not under y. The numbers are not on the other side. So step by step, we need to make the question friendlier. So here for the equation 1, I'm going to add 7 to both sides. So with the form that I'm used to, x plus 3y, of course 7 and minus 7 cancel. 0 plus 7 is 7. Next one, I have to do the same here. Plus 3 on both sides. So like here, when minus 7 and 7 cancelled, here I got minus 3 and plus 3 cancelled, and we have 2y minus x equals 3. The problem is now x is not under x. So I need to just switch them round. Write this one first, and then x minus x next. So we have x plus 3y, equation 1 is okay. Putting minus x first, and then plus 2y. Now I can see what to eliminate. Eliminate x by adding here I just mentioned eliminate x. By adding plus x and minus x is gone. 3y plus 2y, that's 10y, equals 10. Divide both sides by 10. So y equals 1. Then as before, sub the letter you found, y equals 1 in equation 1 is my choice. So we have x plus 3y equals 7. X plus 3 equals 7. Remove 3 from both sides. X equals 4. Do a mental check in equation 2, because you use 1 for substitution. Minus x, that becomes minus 4, plus 2 lots of 1, minus 2. You can see now by checking y equals 1 and x equals 4 does not check in the equation that I did not use, number 2. So that's an example that you really should check. I made a mistake on purpose to end up with the wrong answers. So you can see checking is important. So in the exam, when you check and the answer isn't satisfying the other equation that you did not use substitution in, you need to go back and see where the mistake could have been. By checking, this is where I purposely made a mistake for you. 3y plus 2y is not 10y. That was 5y. So let me just replace now with the correct answer. That's 5y. That's 5. That's 5. So my y would be equal to, not 1. Now replace the correct value. Instead of 1, you replace 2. 3, 2 becomes 6. Remove 6 from both sides instead of removing 3. So you end up with the x value as 1. Now let's check these new answers now. Let's now check, see if my new answers fit the equation 2 that I haven't used for substitution. Minus 1 minus x plus 2 lots of 2, which is 4, minus 1 at 4 is plus 3. So these are correct and these were incorrect. So this was our last lesson on simultaneous equation. I've gone through every combination of equal sign, different signs, same coefficient, different coefficient, and also by means of showing you how to check your answers, and in case it's wrong, how to go and correct yourself. I've tried to do it in very systematic order so you can actually enjoy maths as you learn. That has always been my aim, to make maths enjoyable for you. So till next lesson, bye.